Well, let me introduce you to the heroes of our story, geochemists. Think of them as the forensic scientists for the natural world, the detectives on the front line of planetary health.
So what exactly is geochemistry? In a nutshell, it's the science of the Earth's chemical makeup. Geochemists study how different chemical elements are spread out and how they move through our planet's systems.
That's really the best way to think about it. They're basically chemical detectives. They track elements and compounds, some good, some not so good, to see how they travel through and affect marine ecosystems.
You know, there's an invisible poison spreading through our oceans. It's slowly working its way onto our dinner plates, and honestly, most of us don't even know it's there. So today, we're going to unpack the story of mercury.
For billions of us, seafood is a vital source of protein. It's healthy, right? But here's the catch. It's also the main way that a lot of us are exposed to a really powerful neurotoxin. The very fish we depend on are soaking up a poison that starts its journey in the smokestacks of our modern world.
So, let's meet the main villain of our story, methylmercury. Now, there are a few different forms of mercury out there, but this is the one we really need to worry about. Because it's an organic form, it gets into living cells super easily and just stays there. It builds up, becoming more and more potent as it climbs the food chain.
All right, so here's our roadmap. We're going to follow this toxin's entire journey.
So why is this such a huge deal? I mean, what does it actually do? Let's dive into the real-world health consequences.
Well, first off, methylmercury is a powerful neurotoxin. The world really woke up to its devastating effects back in the 1950s in Minamata, Japan, where industrial waste poisoned the entire local fish supply, with tragic consequences. For most of us today, the risk comes directly from the seafood we eat. High levels are especially dangerous for kids and developing fetuses, but it's not just a human problem. It can also harm animal populations and throw entire ecosystems out of whack.
That brings up a really critical question. If this stuff is so dangerous, where is it all coming from? Well, the answer, unfortunately, points directly back to us.
So what are we doing to cause this? The main drivers are activities that are pretty central to our industrial society. Burning coal for energy is a massive source. It releases mercury that was trapped in that fuel straight into the atmosphere. Same goes for mining operations, especially for gold and silver, plus a whole host of other industrial processes and even burning our trash. Basically, the engines of our modern world are pumping this toxin into the environment.
So once that mercury is released from, say, a smokestack, how in the world does it end up in a fish in the middle of the Pacific Ocean?
Well, the main pathway is through the air. Mercury gets shot up as a gas, it rides the wind currents, sometimes for thousands of miles, and eventually it falls back down to Earth with rain and dust. They call it atmospheric deposition. And that's how a less toxic form of it, inorganic mercury, gets into the ocean.
But here's a crucial plot twist. This inorganic mercury isn't the form that's so dangerous to us. For that to happen, the ocean itself has to perform a kind of dangerous alchemy, transforming it into the true villain of our story.
This diagram here gives you a sense of the really complex cycle that happens next. See, that inorganic mercury that falls from the sky doesn't just stay that way. It gets caught up in all these chemical transformations in the ocean. And the most critical one, the one we really need to focus on, is the conversion to methylmercury. This is the moment the poison gets activated.
And once methylmercury has that key, it begins its relentless climb right up the marine food web.
This is where a couple of really important concepts come into play: bioaccumulation and biomagnification.
It all starts at the very bottom. Tiny phytoplankton absorb just a little bit of methylmercury. Then small fish come along and eat thousands of these phytoplankton, so all that mercury gets concentrated in their bodies. Then, of course, larger predator fish, like the tuna and swordfish that many of us love to eat, they devour hundreds of those smaller fish. The mercury doesn't break down, it just keeps building, reaching its most dangerous levels in those top predators.
And we're starting to see the effects of this really clearly in some of the most remote parts of the world. Because of unique weather patterns and the impacts of climate change, the Arctic is getting hit especially hard. Some animal populations there are already struggling to reproduce because of high mercury levels, and it's serving as a major warning sign for the rest of the planet.
This really forces us to look ahead. The mercury we release today doesn't just vanish, it becomes part of a long-term global cycle, our legacy.
And this problem doesn't exist in a bubble. It's deeply tangled up with climate change. A warming ocean, for example, could actually speed up the microbes that create methylmercury. Melting permafrost could release huge amounts of mercury that have been trapped in ice for centuries. All these complex interactions make the future really, really hard to predict.
Now, the world is taking action. There's an international treaty called the Minamata Convention, named after the site of that first awful poisoning. Its whole purpose is to cut down on mercury emissions from big sources like coal plants and gold mining. It's a huge, crucial first step, but there's a catch.
And it's a really big catch. We have to deal with our past. Even if we could magically flip a switch and stop all human-caused mercury emissions tomorrow, the legacy mercury that's already cycling through our planet would continue to affect the oceans for decades, maybe even centuries. The mercury we released yesterday is our problem for a long time to come.
Which leaves us with this final, critical question. The choices we make now are going to define the health of our oceans and ourselves for a very, very long time.
And that's our look into the ocean's mercury mystery. Thanks so much for joining the investigation.